In scenario 1, with a switch neutral and the transfer switch, reworking involves separating the neutral block in the main breaker panel. Run a separate ground wire from the neutral block to the grounding electrode. In the main breaker panel, the neutral and ground bars must be separated. No additional disconnects are required in this scenario. In scenario 2, with no switch neutral and the transfer switch, no reworking is required. Grounding and neutral separation is not required. The neutral and ground remain bonded in the main breaker panel. A disconnect switch must be installed on the generator side of the transfer switch for maintenance and safety purposes. In both scenarios, a transfer switch with the switch neutral must be listed and labeled for use in its application. The grounding electrode used must meet the requirements of National Electrical Code Section 250.52. The generator must be properly grounded according to National Electrical Code Section 250.30. The installation should be inspected and approved by the local authority having jurisdiction. Now let's delve deeper into the technical aspects. When installing a generator with a transfer switch, the primary consideration is ensuring a safe and code-compliant installation. This involves understanding how the neutral and grounding systems interact and how to properly isolate or bond them depending on the type of transfer switch used. A switch neutral transfer switch interrupts the neutral conductor when the generator is providing power. This is crucial for preventing circulating currents and ensuring proper operation of ground fault protection devices. Without a switch neutral, a parallel path for neutral current can be created, leading to nuisance tripping of ground fault circuit interrupters or arc fault circuit interrupters and potentially dangerous conditions. When a switch neutral is used, the neutral to ground bond must be removed from the main panel. This is because the generator will establish its own neutral to ground bond when it is running. The separate ground wire run from the neutral block to the grounding electrode ensures that the panel is properly grounded regardless of whether the utility power or the generator is supplying electricity. In a scenario where the transfer switch does not switch the neutral and ground remain bonded in the main panel. This is acceptable because the neutral is never interrupted, and the utility neutral to ground bond remains the primary reference point. However, because the generator could potentially backfeed the utility grid without a switch neutral, it becomes imperative to have a disconnect on the generator side of the transfer switch. This disconnect allows for safe maintenance and prevents the generator from energizing the utility lines during an outage, protecting utility workers and equipment. The disconnect should be readily accessible and clearly labeled. Regarding grounding electrode requirements as per National Electrical Code Section 250.52, acceptable grounding electrodes include metal underground water pipes, metal frames of buildings or structures, concrete encased electrodes, ground rings, and rod and pipe electrodes. The choice of grounding electrode depends on site conditions and local codes, but it must provide a low impedance path to ground. Typically, a ground rod is driven into the earth and connected to the grounding system with a listed grounding electrode conductor. National Electrical Code Section 250.30 outlines the requirements for grounding separately derived systems, such as generators. This section specifies the size of the grounding electrode conductor, the bonding jumper requirements, and the location of the neutral to ground bond. The generator's neutral must be bonded to the generator frame, and a grounding electrode conductor must connect the generator frame to the grounding electrode system. The size of these conductors is determined by the generator's output capacity and the applicable tables in the National Electrical Code. When installing a generator, several other factors should be considered. Firstly, the generator must be sized appropriately for the load it will be serving. This involves calculating the total power requirements of all appliances and devices that will be running simultaneously and selecting a generator with sufficient capacity. Secondly, the transfer switch must be compatible with the generator and the electrical system. It should be rated for the voltage, amperage, and frequency of the system. Thirdly, all wiring must be done in accordance with the National Electrical Code and local codes. This includes using the correct wire size, conduit, and fittings. Fourthly, the generator should be installed in a well-ventilated area to prevent overheating. It should also be protected from the elements to prevent damage. Fifthly, the generator should be tested and inspected by a qualified electrician to ensure that it is operating safely and correctly. This includes verifying the voltage, frequency, and grounding system. In addition, regular maintenance should be performed on the generator to ensure that it remains in good working condition. This includes changing the oil, replacing the air filter, and inspecting the spark plugs. The generator should also be started and run periodically to keep the engine lubricated. Finally, it is important to be aware of the potential hazards associated with generators. Generators produce carbon monoxide, a deadly gas. Therefore, the generator should never be operated indoors or in a confined space. It should also be kept away from flammable materials. Generators also produce electricity, which can be dangerous if not handled properly. Therefore, it is important to follow all safety precautions when working with a generator. In summary, understanding generator neutral and grounding separation, along with proper disconnect installation, is critical for ensuring a safe and code-compliant residential generator setup. Whether using a switched-on switch-neutral transfer switch, adherence to National Electrical Code guidelines and local regulations is paramount. Always consult with a qualified electrician for installation and inspection to guarantee the safety and reliability of the system. Furthermore, it's essential to elaborate on the specific components and wiring practices involved in generator installations. The grounding electrode conductor, often referred to as the GEC, plays a vital role in providing a path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses. Its size is determined by National Electrical Code Table 250.66, which correlates the size of the GEC to the size of the service entrance conductors. For instance, if the service entrance conductors are 2/0 American wire gauge copper, the minimum size of the GEC would typically be 4 American wire gauge copper. The bonding dumper, as mentioned earlier, connects the generator frame to the neutral conductor in separately derived systems. Its size is determined by National Electrical Code Table 250.102. The bonding dumper ensures that the generator frame is at the same potential as the neutral, preventing voltage differences that could pose a shock hazard. The transfer switch itself is a critical component. It is designed to safely switch between the utility power and the generator power, preventing backfeed to the utility grid. Transfer switches come in two main types: manual and automatic. Manual transfer switches require the homeowner to manually switch between the utility and generator power, while automatic transfer switches automatically switch to generator power when a power outage is detected. Automatic transfer switches offer greater convenience but are typically more expensive. When selecting a transfer switch, it is important to consider its amperage rating, voltage rating, and number of poles. The amperage rating should match or exceed the amperage rating of the main breaker panel. The voltage rating should match the voltage of the electrical system. The number of poles should match the number of conductors in the system. For example, a 240-volt single-phase system requires a 2-pole transfer switch, while a 208-volt 3-phase system requires a 3-pole transfer switch. Wiring practices are also crucial for safe and reliable generator installation. All wiring must be done in accordance with the National Electrical Code and local codes. This includes using the correct wire size, conduit, and fittings. The wire size must be adequate for the amperage of the circuit. Conduit protects the wiring from physical damage. Fittings are used to connect the wiring to the various components. When running wiring between the generator and the transfer switch, it is important to use flexible conduit to allow for movement and vibration. The flexible conduit should be securely fastened to both the generator and the transfer switch. All connections must be tight and secure. Loose connections can cause overheating and electrical fires. Grounding is another important aspect of wiring. The generator, transfer switch, and main breaker panel must all be properly grounded. This provides a path for fault current to return to the source, protecting people from electric shock. The grounding electrode conductor should be connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode should be installed in accordance with the National Electrical Code. Testing and inspection are essential steps in ensuring a safe and reliable generator installation. After the installation is complete, a qualified electrician should test the system to verify that it is operating correctly. This includes checking the voltage, frequency, and grounding system. The electrician should also inspect the wiring to ensure that it is properly installed and that all connections are tight and secure. Regular maintenance is also important for ensuring that the generator remains in good working condition. This includes changing the oil, replacing the air filter, and inspecting the spark plugs. The generator should also be started and run periodically to keep the engine lubricated. In addition to the technical aspects, it is important to consider the safety aspects of generator installations. Generators produce carbon monoxide, a deadly gas. Therefore, the generator should never be operated indoors or in a confined space. It should also be kept away from flammable materials. Generators also produce electricity, which can be dangerous if not handled properly. Therefore, it is important to follow all safety precautions when working with a generator. Before starting the generator, make sure that all appliances and devices are turned off. This will prevent the generator from being overloaded. Never refuel the generator while it is running or hot. Allow the generator to cool down before refueling. Wear appropriate personal protective equipment such as safety glasses and gloves when working with a generator. Be aware of the potential hazards of electricity and take precautions to avoid electric shock. If you are not comfortable working with electricity, hire a qualified electrician to install and maintain your generator. In conclusion, installing a generator with a transfer switch requires a thorough understanding of electrical codes, wiring practices, and safety precautions. By following the guidelines outlined in this discussion and consulting with a qualified electrician, you can ensure a safe and reliable generator installation for your home. Remember that local codes and regulations may vary, so it is always best to check with your local authority having jurisdiction before starting any electrical work. This comprehensive overview should provide a solid foundation for understanding the complexities of generator installations and the importance of proper grounding, neutral separation, and disconnects. Now let's talk about the importance of proper labeling. All components of the generator system should be clearly labeled to avoid confusion and ensure safe operation. The transfer switch should be labeled to indicate which position connects to the utility power and which position connects to the generator power. The disconnect switch on the generator side of the transfer switch should be labeled to indicate that it disconnects the generator from the electrical system. The main breaker panel should be labeled to indicate that the neutral and ground are separated when a switch neutral transfer switch is used. The grounding electrode conductor should be labeled to indicate that it connects to the grounding electrode. Proper labeling helps to prevent accidents and ensures that the system can be operated safely by anyone, including homeowners, electricians, and emergency personnel. Another important consideration is the location of the generator. The generator should be located in a well-ventilated area, away from flammable materials, and protected from the elements. It should also be located in a place where it will not be a nuisance to neighbors. Many municipalities have regulations regarding the placement of generators, so it is important to check with your local authority having jurisdiction before installing a generator. The generator should be placed on a level surface to prevent it from tipping over. It should also be secured to prevent it from being stolen. The area around the generator should be kept clear of debris to prevent fires. The exhaust from the generator contains carbon monoxide, so it is important to ensure that the exhaust is vented away from buildings and occupied areas. The exhaust should be directed away from windows, doors, and ventilation intakes. A carbon monoxide detector should be installed in the home to alert occupants if carbon monoxide is present. The generator should be operated in accordance with the manufacturer's instructions. The instructions should be read carefully before operating the generator. The generator should be started and stopped in accordance with the instructions. The generator should be refueled in accordance with the instructions. The generator should be maintained in accordance with the instructions. If you have any questions or concerns about operating the generator, contact a qualified electrician. In addition to the points already covered, it's important to discuss load management when using a generator. Generators have a limited capacity, and it's crucial to avoid overloading them. Overloading a generator can damage it and can also cause it to shut down, leaving you without power. To avoid overloading the generator, it's important to prioritize the loads that you need to run. Start with essential loads such as refrigerators, freezers, and medical equipment. Then add other loads as needed, being careful not to exceed the generator's capacity. Consider using energy-efficient appliances and devices to reduce the load on the generator. Turn off lights and appliances when they are not in use. Avoid running multiple high-wattage appliances at the same time. Use a load management system to automatically control the loads on the generator. A load management system can monitor the generator's output and automatically turn off non-essential loads when the generator is approaching its capacity. This helps to prevent overloading the generator and ensures that essential loads continue to receive power. When using a generator, it's also important to be aware of the potential for voltage fluctuations. Generators can sometimes produce voltage that is higher or lower than the normal voltage. These voltage fluctuations can damage sensitive electronic equipment. To protect electronic equipment from voltage fluctuations, use a surge protector. A surge protector can absorb excess voltage and prevent it from reaching the equipment. Use a voltage regulator to stabilize the voltage from the generator. A voltage regulator can maintain a constant voltage output regardless of the load and the generator. Avoid using the generator to power sensitive electronic equipment if possible. If you must use the generator to power sensitive equipment, take extra precautions to protect it from voltage fluctuations. It is also crucial to discuss the importance of permits and inspections. In many jurisdictions, a permit is required to install a generator. The permit process ensures that the installation meets all applicable codes and regulations. An inspection is typically required after the installation is complete. The inspection verifies that the installation was done correctly and that the system is safe to operate. Contact your local authority having jurisdiction to determine the permit and inspection requirements in your area. Do not attempt to install a generator without obtaining the necessary permits and inspections. This could result in fines or other penalties. It could also create a dangerous situation. In summary, installing a generator with a transfer switch is a complex process that requires careful planning, execution, and adherence to codes and regulations. By following the guidelines outlined in this discussion and consulting with a qualified electrician, you can ensure a safe and reliable generator installation for your home. Remember that safety is always the top priority. Take the time to learn about the potential hazards of generators and take precautions to avoid them. With proper planning and execution, you can enjoy the peace of mind that comes with knowing that you have a backup power source in case of a power outage.